For the acceleration lab, you'll be rolling a car down a ramp. What I want you to do is find the relationship between the acceleration of the car and the angle theta, which is the angle of the ramp between the ramp and the ground. Once you've done this, you want to get several different angles, measure the accelerations, and then graph that. You want to extrapolate the graph to the angle where theta equals 90 degrees. So in other words, I want you to figure out what the acceleration is if this car were going straight down, if you dropped it instead of rolling down a ramp. In order to do this problem, you need to think about what you can measure and what you're trying to find. In this problem, our unknown variable is the acceleration. This is what you want to find. So what information are we given? We're given the distance that the car travels, and that's something that you'll have to measure. And there's something else that you can measure, which is time. If you look in your book, you'll realize that there is an equation involving distance, time, and acceleration. You will have to rearrange it to solve for acceleration. Here's one little tiny clue. What is the initial speed at the top of the ramp? Because the equation that you're looking for will have initial speed in it. So there's a little hint. Once you figure out the equation, measure this carefully, you should be able to calculate the acceleration. Again, do it for at least 5 angles, and then when you do your graph, make sure that your range for the angle goes up to 90 degrees so you can extrapolate the line up to that point and determine what the acceleration is if the car were falling or going down a ramp at 90 degrees. In other words, falling. Alright, I'll be walking around the room to help you. Just please don't break the cars. They're fragile, they're expensive, they're about $2,000 a piece. In other words, we can't order them until next year, and well, they're expensive, but you don't want to break it. Please.